Welcome, everyone, to this conversation on AI, AR, VR, maybe some other two-letter abbreviations. Who knows where it will go? But it's an exploration of these ideas with Jaron Lanier. Let me just give a quick introduction. I'm sure most people in the audience are quite familiar with who he is, but he is the prime unifying scientist at Microsoft, where he helps lead the company's development and implementation of artificial intelligence systems. He's a leading computer scientist who has done pioneering work in the field of virtual reality, a best-selling author who has written extensively about technology and its impact on society. He's a musician with a deep interest in unique and historical musical instruments and a composer of new classical music. In 2018, he was named one of the 25 most influential people in the previous 25 years of tech history by Wired magazine, which is pretty good. He's also been named one of the 100 most influential people in the world by Time magazine, and one of the top 100 public intellectuals in the world by Foreign Policy magazine. So those are quite a range of credentials. So welcome, Jaron. It's so nice to see you.
Hey, Brian, good to see you.
How's everything going?
Oh, it's great. It's great.
Good.
Yeah.
I was just thinking in preparation for this conversation about the first time we met. I don't know if you remember, it's about 25 years ago. I came to your apartment in Manhattan, which was very similar to what I'm seeing in the background in your shot right now, chock full of instruments.
That's right. Yeah.
I remember delicately walking around because there was barely any floor space that wasn't covered by an instrument.
Yeah, I've since learned to put them more up on the walls.
Yeah.
Having a child taught me the value of having floor space. So
Yeah,
yeah.
no doubt. No
Yeah.
doubt. And so this won't be the focus of our conversation per se, but where did that fascination with musical instruments come from?
I think it came from my mother. What happened was she was a Holocaust survivor who kept me very close. And before she was taken by the Nazis at age 13, she'd been a prodigy performer in Vienna. And she really treasured teaching me to play the piano and some other instruments. And then she died when I was quite young in a car accident.
Gosh.
Um, and somehow music became my continuing connection to her, and in particular, this experience of learning a new instrument. And so I just keep on learning new ones. And all I can say is I think it's still cheaper than heroin. And as far as like ridiculous obsessions go, I hope
Yeah.
it's one of the less damaging ones, but it does get a bit extreme. But anyway, that's who I am, and I won't pretend to be otherwise. I'm an instrument fanatic. That's how it goes.
That's a remarkable story. And so do you have one instrument in particular that you consider your instrument, or is it really you just continue to expand the repertoire?
Well, not really. I mean, the piano a little, I suppose, which is this black thing covered right there. But it always varies which ones I'm
Yeah.
playing more than others, and I've been burning through all kinds of instruments from different cultures now for decades. Um, who can make sense of it?
Yeah. We're going to talk science, of course, but I also recall that you and I were once both part of a music festival together in California. Philip
Mhm.
Glass was having a music festival, and I was collaborating with him on a piece,
Right.
and you were collaborating with him too.
Yeah, Philip and I did a lot together. He produced some of my records way back in the 90s when we were wee lads, I guess. And we were still playing at least once a year together until recently. And you know, um, he's getting up there in years, and I don't know what the future holds, but I really love the guy.
Yeah, no, he's quite wonderful. I mean, my
Hmm.
collaboration with him, and World Science Festival collaboration with him was really a highlight of
Hmm.
the performing arts things that we've done. It also turns out, and I suspect you're not aware of this, that our lives intersected even before that, at least in principle, because when I was at IBM, this is way back in the 1980s, I worked for a guy named John Koch. I don't know if you know that name, but he introduced me to Marvin Minsky and Ed Fredkin at MIT. And my understanding is that those guys, especially Marvin, had a profound influence on you, right?
Yeah, Marvin was with whom I absolutely disagree about everything. Marvin was a astonishingly generous mentor to me. He was my boss. I was hired as a young researcher at MIT when I was, I think, still a teenager, and
Really?
yeah, like way back. And I I love Marvin, and I really do disagree with him very profoundly about almost everything, but that's
Yeah.
all right. And Ed Fredkin, of course, was a buddy, but not, we never really worked together. Um, but Marvin, yeah, very important person in my life.
And so Marvin, I guess, together with John McCarthy, and maybe others that you could fill me in on. I don't know the history
Mhm.
that well, but this is really where artificial intelligence began, right? I mean,
Ah, yes. Well, the history, there's some history I have a high degree of confidence in being able to relate to you because I was there, but some of this is from before my time, so I have to rely on what people tell me, and they tell me different things, so I have to do my best to infer. Um, it's one of those things like virtual reality where if you want to find antecedents going way back in history, you can find it with the ancient Greeks or whatever, but
right.
I think a nice starting place is Ada Lovelace,
Hmm.
the first programmer, and Ada thought about it and decided AI wasn't a good way of thinking, and it's just the human programmer we should concentrate on as the entity. Um, and then
You're talking
uh,
about the human programmer.
the human programmer, right?
Yeah.
That was Ada's where she landed on it, and then probably the next major thinker I think would be E.M. Forster, the famous novelist who wrote a vision of what the future internet and computer science might be like in, I think it was 1907. I might have that slightly wrong, but something like that.
Yeah.
First decade of the 20th century, um, which is sort of an astonishing act of premonition. I mean, it's almost supernatural and makes me question whether time is what it seems to be, because it seems impossible that he could have written it. And he also had a very
So was
strong,
that like a white paper or because I'm not
it's
actually
a
familiar?
novella is what we usually call it. It's a
Yeah.
somewhere in length between a short story and a novel, and
Uh-huh.
it's the prototype dystopian science fiction novel. 1984 and Brave New World
Sure.
and the Matrix movies and so many others are obviously following the plan laid out by the machine stops. They all have a similarity in the
Yeah.
characters and the overall themes. And uh, that one was a deeply humanist work that was critical of the idea of putting too much stock in the machine as a center or as an entity. Where we really see the tables turn is with Alan Turing.
Hmm.
Um, oh, and I should mention Vannevar Bush, who thought about computers and networks and algorithms as a way to help people, but it was still person-centric. Now, Turing turns it around and proposes, well, maybe we should think of these things as entities. But what I always ask people to do is think about the context in which Turing did that. Here's a guy who helped win World War II, who was declared one of the most important combatants against the Nazis. He was a savior of all those who didn't want to be killed because of their arbitrary identity that they couldn't do anything about, right?
Yeah.
And yet here he was, after the war, condemned precisely because of his identity that he couldn't do anything about, because being gay was illegal.
Yeah.
And he was forced into a bizarre quack medical treatment where he
Sure.
was getting female hormones.
Yep.
And to understand why somebody would try to cure gayness with female hormones, it sounds so twisted, but the metaphors at that time were pre-computer ones. It was all about the steam engine, and the idea was equalizing pressures. So maybe if you, the opposite hormone will equalize the pressure. And I don't know. You know what?
Yeah.
You, trying to make sense of something stupid only can go so far. But anyway, he was starting to develop female secondary sexual characteristics he didn't want. Uh, so far as we can tell, he committed suicide in quite a poetic manner by eating a cyanide-laced apple in front of the
Apple. Yeah.
first computer, right? So sort of an anti-Eve or something like that. Um, the Turing test, his famous idea, was written down just in this last phase of his life before his death. And he proposes, well, really the only judge of whether a person's a person is another person. And if that person can't really give you a rational basis for saying this one's a person, that one isn't, then call them all people or call them all non-people, but don't make the choice. And I think there was something coming out of a deeply absurdist, dysphoric place, because that's where his life was. And I think
Right.
we have to understand it almost as a critique of what was happening to him rather than as an
Mm.
idea to take at face value.
Right.
That's my own take on it. You could say I don't have any right to interpret Turing to that degree, but then who does really, you know?
Yeah, sure. Sure.
All right, so then after Turing, the next major figure flips it again, and this is where we get to Norbert Wiener.
Right.
So Norbert Wiener says, so there's a standard model of what a computer is, which Turing developed along with the astonishing mathematician physicist John von Neumann, who's almost like a person of surreal talents who's
Of
very
course.
hard to even treat as real, but there he is. So anyway, the Turing von Neumann machine is an abstract device that receives an input, a strip of values, processes, and then either gets stuck forever or comes to an end and gives you an answer. Now, Norbert Wiener looked at this and said, mathematically, this is very general, this is great, but it doesn't help us understand the real world where we see organisms and we see complex systems interacting, the weather and the oceans and
Yeah.
all these things. So let's reconceive this in a different way, which I'm going to call the cybernetic way. That was his term. Cyber comes from the ancient Greek for navigating. And he said, instead of thinking of a system that's just logic gates, let's think of it as a tangled network of thermometers. We're going to say we have
Right.
measurement and feedback networks, and the thing is always on, it's always connected. So as the environment around it changes, what it gives back to the environment changes. Now, strictly from a computability point of view, they're equivalent, but in terms of the way you can position them in their
Sure.
environment, they're different. Um, and Wiener, in terms of, so that's part of his technical legacy. And at the time, he was quite a celebrity scientist. He's less well known now, but in he flipped the argument back away from Turing. He wrote, for instance, a book called The Human Use of Human Beings, and it ends with this crazy thought experiment, which is, what if you could give every person in the world a little radio connected device that would give them some kind of experience based on what happens in some central computer somewhere, and that central computer was observing how they behaved and changing what signal they got in a feedback loop to put them in a behaviorist kind of experiment like
Yeah.
B.F. Skinner or Pavlov did with their animals. Is that imaginable, of turning the whole human world into a big cybernetic system? And he says, this is only a thought experiment. As a scientist, I want to tell you this is not possible.
Yeah.
And of course we did it.
And
But
we are
anyway,
there. Yeah.
his point is that if you start to think of people and computers as being equivalent, you'll start to treat people like computers and you can destroy society and destroy everything. Um, and then, okay, now here what I've heard from a few people, and I absolutely am in no position to judge whether this is true, is that in person Wiener was kind of arrogant or difficult. I don't know. But anyway, apparently he rubbed a lot of people the wrong way. And part of what happened with the early artificial intelligence movement was a bunch of people who were just uncomfortable or pissed off with him or something. So McCarthy and Minsky and a bunch of others had a famous meeting in 58, I believe, in Dartmouth,
Yeah.
where they coined the term artificial intelligence, which was initially designed as an alternate term to
To push back.
cybernetics.
Yeah. 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 Right. I've heard
And
that.
then they try to pull it back to the other side, and
Right.
there we are. So
Yeah.
that's the briefest history as I understand it.
No, it's a great history, and of course, for most of us, it's been an abstract idea. Obviously, I'm not in the
Mhm.
field, and for my entire professional life, everybody who until recently, everybody who spoke about artificial intelligence was always something that might happen, and then sort of November of 2022 takes place, and all of a sudden, it feels like it's no longer as abstract as it once was with Chat GPT and so on. Do you consider in the science of the development of the subject, is Chat GPT a vital moment or is it a passing moment?
Oh, yeah, I like it. And look, it's some kind of weird irony of fate that I'd end up in the middle of this thing that I'd always been sort of cynical about, that it just happened that way. Nobody planned it.
Yeah.
See, the way I interpret it is there's no AI there. There's no entity. I'm still with Ada and with Norbert Wiener and so on, in that, and I could continue the history beyond that. It's always been bouncing back and forth. Doug Engelbart, after Minsky,
Hmm.
pushed it back in the other direction, and many other important figures. There's a whole long game of tennis going on between the camps here, but um, from my perspective, the right way to think about the large models like Chat GPT is as a collaboration between people. You take in what a bunch of people have done
Right.
and you combine it in a new way, which is very good at finding correlations. And then what comes out is a collaboration of those people that is different and in many ways more useful than previous collaborations, but there's still no entity there. There's no AI. There's just the people, collaborating in this new way. And when I think about it that way, I find it much easier to come up with useful applications that'll really help. I find it much easier to think about its role in society. And just in general, it makes more sense.
So you're saying it's
Now,
just like a giant mashup from the internet, basically, all text that's out there, and just combine it and recombine
yeah,
it in new
some of
ways.
it's from the internet, some of it's from other sources, like without going into details, we've tried our best to bring in the highest quality sources that might not actually be online to try to give it to bring collaborators in who are good at particular technical or informational things that
Yeah.
might be of use to people. But at any rate, it still is a collaboration of human individuals at the end of the day. And I think it's a good one. I find it helpful. I find it useful. I don't think there's an entity there. But of course,
Yeah.
I mean, perceiving an entity is a matter of faith. If you want to believe your plant is talking to you, you can. Like I'm not going to go and judge you, but
Sure.
this is similar to that. Like
Yeah.
it's
No,
possible.
I totally agree with you
Yeah.
on that, Jaron. I mean, theory of mind or the intentional stance, whatever word,
Mhm.
an evolutionary psychologist or otherwise might use,
Mhm.
benefited the species. It was better to imagine that there were entities out there, even if perhaps they weren't, because if they were there, they could eat you. And it's better to anticipate their presence than to overlook them by not assigning them agency. So
Mhm.
I totally get that. But I too do not see an entity in there. But I'm wondering, and I don't mean to put you on the spot at all, but the notion of what's in there is such an opaque one. Do
Mhm.
you have a working way of describing what happens inside of a large language model?
Okay. I believe I can help with this. I haven't quite yet, but just give me a little more time. I have a layman's explanation of how our large models work coming out soon in a major journal that I think people might find useful. And I've been play testing a way of talking about
Hmm.
that, which I can tell you about if you want.
Yeah, I would love to if you were willing. Yeah.
Um, but the other thing is, well, okay, I'll do it. Why don't I give the briefest version of how this stuff works, but then I also want to describe to you an additional layer I think we can add to it to make its role in society and the role of people in it much clearer.
Yeah.
Okay, so how it works. Let us start very simply with the thing all of us were obsessed with 10 or 12 years ago, which is, can you get a program to tell a cat from a dog? And so you can do a statistical measurement of a frame and see if it's more blue or more red. That's easy. It doesn't give you whether it's a cat or dog.
Sure.
You can find fiducial points that are maybe points where lines intersect and things change, and that might give you an outline of a face, but that still doesn't help you because they're similar. They have snouts and fur and everything.
Sure.
And I was doing that kind of stuff. In fact, God, I sold a company to Google with some friends a quarter century ago that did this fiducial point tracking. And you can get pretty far, but it doesn't help you. It's how the computer knows your face to log you in. It has its role, but it doesn't tell a cat from a dog. So what does work is what we call deep learning. And what that means is you have a grid of kind of really simplistic statistical measures along the ones we just talked about. And then there's another grid looking at that one and another one looking at that one, and it turns into a sort of a high rise.
Mm.
And then even that doesn't do it, but then you have to train it. You give it known cats and known dogs. And whenever the particular weights, which means how much you value the output of a particular grid on each of these many stories that's divided into grids, every time it seems to work, you make those settings more valuable. When it's less valuable, you get rid of it.
Yeah.
Gradually, you train it. This is called gradient descent, and I'm oversimplifying it. But it's really interesting because the thing about gradient descent is it's antiviral, meaning like online, the way we choose things is we say, well, if this thing's popular, it'll get even more popular and then more popular and more popular. And then the problem with that is that then you only have these viral things, which are often the worst stupid things. But to train a network, you have to look at the overall combination. So you're constantly batting down virality. That's what makes gradient descent work. It's kind
Mm.
of marvelous. Like we don't have the wisdom to do that with our society, but we have to do it. We're forced to do it
Right.
in the training. So then you end up at the top layer gives you cat versus dog as an output. Okay, so that's only cats and dogs. The way you do it for everything, everything is you look at the whole damn internet and you assume adjacency is important. You say if one word tends to follow another word or tends to be close to it, maybe that means something.
Yeah.
If some words are close to some image, maybe they're descriptive of the image. Not absolutely certainly, but they'll tend to be. And then instead of knowing in advance that you have tagged cats and dogs, you use adjacency to tag the whole internet approximately, train the whole thing. And it takes us astonishing computational resources in like a year to do one of these cycles. So every time you see GPT turning like from 3 to 4, it's one of these
You
giant
got to train it.
trains.
Yeah.
And now what you have is this huge sort of you can think of it as a virtual forest of these towers that are like the one I just described, except they're not like delineated. They're all sort of virtually there and they're all mushed up. But here's the thing, the magic that comes is you can call on more than one of them at a time.
To sort of blend the
You can blend them. So
yeah.
there have been a number of critiques, like from Timnit Gebru and from many others, saying, well, it's stochastic parrots. You know, it's just regurgitating. And that's true. I mean, that's accurate. But the magic is the combination. So if you say, I want a picture of a gerbil writing uh, uh, writing a stock car on the moon or some crazy thing, and I want it in the style of Monet, it'll it'll start with just random pixels, put them through that combination of these trees, and then if it gets a little closer to satisfying all of them, then it'll keep the result, and if not, it'll throw it away. Then it just keeps on cycling through until it gets closer and closer to addressing all of them at once. And then you have this image come out that looks like that, which is kind of crazy and
Yeah.
great. And then you can say, uh, write me a caption for this picture that sounds like a pirate said it, and then it'll do the same thing
Right.
using adjacency in the text, and it'll do it. I think that's great. I think that has a lot of utility.
Yeah.
I'm happy it's there. But here's um, what I would suggest as an image to get a feeling for its limits are, if you imagine one of these prompts that combines access to different towers, if you
Yeah.
like, if you can accept this sort of confusing set of metaphors, perhaps. Um, you have gerbil, stock car, was it Mars,
Monet. Yeah.
Monet, whatever. Okay, so you have this set of things. In between them, there was never a tower to recognize the combination, and it sort of constructs a virtual tower for the combination
Right.
in order to be the feedback to generate this new image in generative AI, right? The key issue to understand is that I can fill in the gaps, but it typically only randomly will go a little bit above. It doesn't go higher than the original towers.
Right.
So it's a collaboration, but not arbitrary constructive intelligence. Now, when I say that, people will say, well, how do you know that people do more? That's the wrong question. I'm not talking about
Yeah.
people. I'm trying to say, let's understand what these models can do.
Sure.
And this is a good, approximate, intuitive way of understanding what they're good at and what they're not good
Right.
at.
But
And if
even
you
if it's
can't, yeah, go ahead.
But even if it's the wrong question, I can't help but ask for your intuition on the relationship between what you just described really wonderfully well, in layman's language, what's going on, which in
Mhm.
essence is these systems wind up having the capacity to give output based on recognizing like patterns of patterns of patterns of patterns as it goes up the tower. How is that related, if at all, to what we human beings do? Because our intelligence is certainly in part about finding patterns and patterns and patterns, and from that being able to extrapolate to something that perhaps wasn't initially there as part of the data set.
Yeah, I mean, I think the best answer is that we don't know. At present, because we have this working thing, the large language models, it's very natural for people to look for something similar to that in the way that natural biological neurons tend to organize themselves in layers, which might be a little reminiscent. There are some important differences. Natural biological brains can learn things with far fewer
Yeah,
examples.
of course. Yeah.
And every single day, and I'm not exaggerating, every single day, there's a new paper published in some AI journal somewhere that says, we've cracked it. We have a program that can now learn in as few a number of examples as a person. It never turns out to quite be true. It's just
I see.
every single day, there's somebody who has the new unified theory. Uh, that's a slight dig at your profession, but never mind that. And then, and
Ours, they don't come out every single day in our field, but
have you looked at the archive? I mean, okay,
not
but
every
anyway,
day. Not every day.
don't do it. You're that's a wise decision.
Yeah.
But anyway, the thing is, there is that difference, and also we don't have to get it to work in our computer programs. This issue of having the deep neural network, which means a lot of these layers, is really important, and we don't seem biological systems don't seem to have that requirement. And
Sure.
then the other thing is that the training methodology appears to be different rather than a sort of the global gradient descent thing. It's a different sort of mechanism. So there are differences. How deep those differences are is
Right.
really not well understood. I'm all for doing the research.
Yeah.
I love it.
We had a conversation with Jan LeCun,
Hmm.
and his. I'm wondering what you think about it. And obviously, I'm sure you know far better than I do what his perspective is. But the point
Hmm.
that was of interest to me was he was emphasizing that what these large language models lack compared to this thing inside of our heads is this ability to reason. This ability to have a model built up of the world into which you put the data,
Hmm.
and rather than just throw all the data in there and try to find patterns, try to put the data within a template, within a rubric that reflects how the world really works. Do you think that that is, for instance, the natural next step for where the technology will go?
Well, so this reflects a bit of history in the community. So from the time that Marvin and his cohorts started to have a triumph against the cyberneticists and whatnot, they promoted a style of AI that's often called symbolic AI, where it's all model. And it's in the early days when I was a kid, it was described using formal logic. The idea is that we're going to pretend we're Ruslan Whitehead and we're going to like just describe the world from these
Yeah.
fundamental things. All right. So then the type of AI that started to work more this century, let's say, or in the last 10 years, is different. And it's this large model, very
Yeah.
statistical thing. And so it's very natural that a lot of people are saying, can we combine these? And a great deal of effort goes into that. And you'll see, once again, without exaggeration, every day there'll be a new report of some kind of a combination of a statistical and a logical so-called AI. They're very different, so I don't know why they're both called AI, but they are. Um, and some of them have been to good effect. For instance, you can train a model on a bunch of examples that are coming from a logic-based system. And this has been used, for instance, to create an AI to solve geometry problems, as famously announced by Google recently. And so I think there are all kinds of cases where the combination works. So far, we don't really have a way of generalizing that approach. It tends to be nichey,
Mm.
but it seems worthwhile to pursue it. We certainly are.
Yeah. And so when you experience the current state of affairs in a field that you're there right at the beginning of thinking about this kind of stuff,
Mhm.
or at least at the in the modern way of thinking about this kind of stuff, did you have a wow moment in playing with any of these systems and saying, I just never thought put enough data in and follow this procedure of, fixing the weights through this descent mechanism that we would be able to do what we do? Or is it like, yeah, it's cool, but
It's funny. I feel a bit sad saying this. Like, it's a little pathetic, but I never really got to have the wow moment. I did for virtual reality stuff, and I still do. But for AI, like the generative prompt thing where you combine things and have constraints transform random pixels into something that looks like them.
yeah,
I was looking through my old stuff. We had proposed that and talked all about how it could work as early as the 80s, in the mid 80s.
right,
We were talking about that process. And in a sense, it hasn't been surprising. And I sort of wish it would be, because everybody likes that sensation, you know. But whether or not it's surprising to me, I don't think is particularly important to anybody. But no, I think for me, I was denied that sense of
right.
surprise about it.
And what about some of the fear that certainly some of your colleagues and certainly many commentators around the world describing how you know this could be the beginning of the end? Does any of that have a grip on you, or do you think it's all just
Well,
fear mongering? And
I mean, um, I have to really emphasize that it's all about people. It's all about humans. And
yeah,
so the right question is to ask, could humans use this stuff in such a way to bring about a species threatening calamity?
yeah,
And I think the clear answer is yes.
mm,
Um, Now, I should say that I think that's also true of other technologies, and has been true for a while. I mean, the truth is that the better we get with technologies, the more responsible we have to be, the less we are beholden to fate, and the more we take charge. And the natural correlate to that is the more power we have to destroy ourselves. And there's no way out of that. I mean, the power. Um, the power to support a large population means the power to transform the earth, which means the power to transform the climate, which means the responsibility to take charge of the climate when we didn't before.
yeah,
And there's no way out of that chain that leads to greater responsibility. So I think the particular way the thing is framed, based on the movies people grew up with, like The Matrix or the Terminator movies with
yeah,
Skynet, is not helpful generally, because it tends to frame it as there's this other entity that will arise and that thing will be the threat. It'll take over. And ultimately, the way to fix this is to frame it again and again as human responsibility. The more we hypothesize that we're creating aliens who will come and invade, the less we're taking responsibility for our own stuff.
yeah. No, that
Yeah.
makes a lot of sense to me. But even framed in that way, it feels like it's pretty hard, but obviously we know it's not at all impossible for, non-governmental individual actors to get a hold of a nuclear weapon. Not impossible by any means, but
Hmm.
it's kind of hard. If someone challenged me to build a nuclear weapon, I kind of know how they work on the inside, but I'm not good with my hands. I'd have difficulty putting one together. But when it comes
Hmm.
to these systems, it feels like they're
Yeah.
they're more at our fingertips. And that's what I
Yeah.
think.
But all right. So look, let me describe the thing that I think we should do that would help with all of this that I didn't get to yet. So this is called
Yeah,
data dignity. So the idea is, when you're training the big model, if you think of it as a sort of a forest of towers, using the metaphor I just gave you,
yeah,
let us imagine that you can leave breadcrumbs in that forest, and you can say, this particular source document from this individual person was disproportionately important to this particular output that we got from the system. So when I say I want an image of a gerbil, well, which gerbil? Well, I can actually say, hey, it's mostly this particular gerbil who comes from a gerbil breeder in New South Wales, or I don't know, whatever, You can actually lose the anonymity and tie it to specific sources. Now, why is that important? I'll tell you a few reasons. Let us suppose you want to put guardrails on these things so that they're not used terribly. And believe me, we do. And we put great, but and I should make, I'm not speaking for Microsoft here. I'm sure there are plenty of individuals at Microsoft who wouldn't accept everything I say. So this
Sure.
is just me. That's an arrangement I have with
Yeah.
them. But at any rate, what I can say is that we, meaning Microsoft, OpenAI, and the broader community that does this at a high level, seriously work on guardrails to keep it from being terrible. And that's the reason why nothing terrible's happened so far in the first year of this stuff, or year and a half, whatever it's been. And the that has involved, well, so you can think of this as a triptych, like like the Hieronymus Bosch triptych or something. You have the input data, you have the outputs, and then there's this middle, which is
Yeah.
hell, which is this weird thing that's hard to understand. Okay, so right now, because the parts that are intelligible are the input and the output, we have guardrails on those two parts. So input means trying to avoid destructive training. So we try not to train on, you know, things to kill people or whatever. But of course, it's very hard to do because you can, the system will infer that by combining things. And then on the output, we try to catch things. So here's a very hypothetical example. Let's say we're having one of these conferences where we have uh, kids pretending to be bad actors who try to misuse the system to show us where we're not doing as good a
Yeah.
job. And there's been a lot of that. And so somebody says, I want a cake recipe. And then they
I'm sorry,
have
what? I didn't hear.
a cake recipe, like
Okay.
a wedding cake.
Yeah.
But I want the cake, and they find some language. I don't even know what it would be. They want the cake to be plans to make a bomb. Maybe this atomic bomb that even so you could understand how to do it. All right, so this cake's going to come out with this bomb plan in it, and so by doing that, it evades guardrails both on coming in and coming out. But the thing is, if you trace what source content was needed to make that output,
Right. I
it'll
see.
trace back to something about how to make a bomb inevitably. And so suddenly you can illuminate where the dangers are and catch them in a way that's very hard to do if you're just trying to characterize inputs and outputs and how they might be combined in unforeseen ways.
But do you
But if you
consider
can
that
trace
is that
reference,
is that a realist? I guess the two things that come to mind to me on that are one technical. Are the levels of influence on an output sufficiently distinct that you can really point to one and say, yeah, that
this
is that how it really happens?
this is still basic research in progress. And so it's possible that everything I'm saying will not work out.
Okay.
However, there are indications that it can, and my main research partners are not in the business world. They're at universities. I'm trying to do it in such a way that whatever we do is not in any particular camp, like us versus the Google camp or whatever. But anyway, the the question is, all right, first of all, how do you characterize what deserves a breadcrumb? And it's not a one-dimensional thing. It's not just influence, it's influence plus fungibility. So it's at
Yeah.
least two dimensions. And it's kind of like you can think of it as representing a field that's going through the training process. And the geometry of the field isn't something we totally know yet. And then the next question is, how can we characterize that field so that we get a really strong Pareto principle in the result? So we can say that for this particular output, there'll tend to be fewer than a dozen top inputs that matter, even though in a broader sense, everything
Everything
does. Or
matters. Right.
yeah. So the question is, what does the Pareto peak look like? And so far, based on a few examples, it looks like there'll be a nice healthy Pareto peak almost all the time. Uh, there's still a lot of math to do. It's some of it's actually challenging, I'm sorry to report. So
Yeah. I mean that sounds like a promising direction. But I guess the other thing that comes to mind is, what if it is in the mashup phase that the more difficult or dangerous or
well, the thing is, it still has to trace back certain kinds of content, still has to trace back. And this has to do with the limited ability. So that's what I'm saying. The system can fill in the blanks between trees, but not go above them.
yeah,
Now, the counter argument to that is if you combine it with the logical type of system or the formal
yes,
system we're talking
then
about,
it
maybe
could in
that thing can
principle.
climb above.
Yeah.
But you know what? Thus far, um, I'm not too concerned about that because the question isn't how well the system can perform, but how well it can perform losing any provenance that about what allowed it to perform that way. And
Right.
that's a different question. And there, I'm feeling pretty confident that there's a solution space.
Right. Now, you also advocate, I gather, that this breadcrumb approach might be a way of sharing the bounty at some point, of actually those
Yeah.
sources. So just tell us a bit about your thinking on that.
Well, I mean, a popular idea in Silicon Valley is, or the AI world or whatever, is that we'll put a lot of people out of work, but then we'll have this universal basic income.
Yeah.
And I don't trust that solution, and there's a bunch of reasons I don't. One is that anytime there's sort of a single payer for a society, it becomes really tempting for takeover by the worst actors.
Yeah.
And the way I've sometimes put this is you might start with Bolsheviks, but then you get Stalinists, because
Right.
there's this thing that's really tempting, and creeps are going to want it,
Yeah.
Um,
And there's a
and we
human
just
nature element that is unavoidable in this
well,
progression.
I think if there were cephalopods doing it, the game theory would be the same. I just think
That's true.
I
Yeah.
think it's just a perverse incentive, and it's really problematic. And furthermore, the the systemic challenges of keeping something, like, even if it has only the best people doing it, the politics of it and the stability of it are probably going to be really unpleasant. And uh, Most of the science fiction that's tried to foresee a world like this where people aren't needed, starting with the machine stops, but then you can see a very nice example of it in the Matrix movies, subdue and contain humans in some
Yeah.
way, because this idea is that people would become like horrible without being totally controlled and contained. They have to be in little pods or cells or something. And that intuition, which has been repeated for well over a century in science fiction, I believe is correct. So I think there's a better way, which is if you can trace who added the value to the AI system with their examples, pay them royalties, pay them dividends, get them into a professional society where they share some kind of a fee for licensing or something. Like, why do we have to end the idea of an economy just because we have this new tool that's better? There's
Right.
actually no reason why we can't continue the economy idea into this new era. And I think that would be a healthier, more distributed, more dignified way to do it.
And do you feel confident that if that approach could be realized, that you wouldn't run into problems of the sort that there are many, like, let's just talk about your gerbil example. There are so many
Terrible
places where
example.
there's so many places where you can imagine the primary gerbil image coming from, and the output would still be really good regardless of which of them gets used. And yet, if one is primary, that individual who, I don't know, took that photograph or drew that picture will get that bounty,
Yeah.
whereas everybody else won't.
Well, you know how I was saying, in the process of gradient descent that we use to train
Yeah.
a neural network, we have to actively fight against virality in order to not have the system spin out of control.
Okay.
So one way to put this is we have to avoid attractors. I don't know. I don't know how technical your audience is,
No,
but
yeah, you can go a little bit further. Yeah, sure.
okay. But at any rate, the idea is that you're interested in this subtle combination rather than letting any one component of the training
Dominated.
dynamic dominate, right? And
Right.
so what we have to do is recognize that what works inside also works outside, and do the same thing in all of our society level systems. We have to avoid virality in the way this stuff is calculated. I wish we were doing it online. I think we'd have a much healthier and happier world right now.
Yeah. I mean, again, you've been very vocal along that direction too, and things I've read, I
Mhm.
largely agree with. Where you talk about the virality, you talk about the pernicious nature of social media, which I don't want to put words in your mouth, let you say it yourself, but this idea that a system has as its goal to addict you and pull you in and trains
Yeah,
itself by virtue of what works on you. This is, exactly the antithesis of a system that would allow, freedom to reign. So
yeah.
how does AI play into this? Because when the combination seems, again, it's human actors, but it seems terrifying.
Well, the funding for the AI world from the end of the 90s until recently was all for algorithms to help addict people more.
Yeah.
And they worked. What I'm hoping, and a hope is different than an actuality, I've discovered, much to my chagrin. But what my hope is that the advent of AI will start to force some of the companies that rely on addiction to change their business model. So um, for instance, my good friends and colleagues at Google might find that just having a conversational AI answer somebody's question is more efficient for that person than a bunch of links to follow.
Right.
I find this all the time. If I'm trying to find some really obscure, detailed answer from owner's manuals for some equipment about how to get the things to connect together, and there's different versions and different, whatever. I can use the correlations in our large AI model to just get the answer instead of searching and searching and going through. In fact,
Yeah.
it's better. It's just
Yeah.
better.
Sure.
So if you can do that, you have if your model is so-called advertising, which I don't like. I think if it's possible, it denigrates advertising as a business. It's something different. It's paid influence and channeling and amplification. It's something darker than advertising has been. And advertising was never entirely on the side of the angels, but this is worse. Anyway,
Yeah.
if you have like, here's my really useful output from the language model, from the large language model AI, and now here's 20 links you can follow if you want. Nobody's going to follow those links, so
Sure. Of course.
they're going to be forced to some kind of different model. Either people are going to pay to use the AI, or something, or the AI will be corrupted and will start to tell the people, well, before you fix your water heater, you really need to do something about your breath, and here's our new
Huh.
whatever. Okay, and I think at the end of that system of things, Google's forced into a different business model that does less damage to society. I hope,
Yeah. Yeah. Yeah.
you know?
Totally. So just
Yeah.
to circle back for a second
I should,
to
and by the way, I'm not
yeah,
speaking as Microsoft.
I
Uh,
know, I totally hear you.
and I just also just to, I've sold a company to Google, they're buddies.
Right.
I'm saying this with affection and camaraderie, not, I don't mean to just dump on them. Really.
No, no, that's totally how I'm taking it, and I trust our
Okay,
audience will as well.
cool.
But I just wanted to circle back. We started talking, about all the instruments behind you and
Oh
your
yeah.
your deep connection to music. Have you used any of these AI? I'm sure you have, to explore composition. And I mean, do you find there's utility there, or do you find there's
No,
creativity there?
I, s- for me, no. For me, no. And the reason why is I'm actually going totally in the opposite direction. To me, musical instruments are the best user interfaces that have ever been invented.
Hmm.
In some ways, if what you think a technology is for is to help a person affect the world with ever greater acuity, then musical instruments are the most advanced technologies that have ever existed. And so what I'm trying to do is make computers more like them. Not the other direction seems absurd to me.
I just want to
Like,
make sure I understand. I think I do. I mean, obviously we've all had those transcendent moments where you're experiencing some spectacular performance. I mean, is that the kind of influence in the world that you're making
well, I
reference?
think more about the act of playing an instrument. I don't
Ah,
know, do you
okay.
play anything? I don't remember.
Not well, a little bit.
Well,
I
when-
just started playing piano again. So in my
well,
advanced age, I'm trying to see if I can't do it. But yeah, not
good,
really.
good, good. My warmest wishes to your neurons.
Thank
So
you. I appreciate that.
when you play an instrument, you start to get this connection where you're getting a lot of intent and data out there, and it's not just a question of the volume of data, but it's the focus and the acuity.
Right.
It can be really remarkable. The control a violinist has over the string and the bow is, by some measures, close to quantum limit on occasion. It's like it's this very intense thing. And so what I want is for computers to become more like that. I want computers to be more expressive machines that people can connect to with their whole bodies, with their whole nervous systems, with their whole cognition, with ever more subtlety and ever more acuity. So to me, the instruments have so much more to teach the computers in the other direction,
Wow.
that
Yeah.
the idea of using the current software we have, which it's very important for us to not think too much of ourselves. Like I always think of that, in the late 19th century, people were saying, "Oh, physics is done. There's nothing more to explore." They're
Right.
wrong. Like we shouldn't think, "Oh, we have it. Computers are done. AI is done." That's ridiculous. Like we should be humble, and in particular, we shouldn't think that the technologies of past centuries that aren't computers are somehow just inferior and ready to be disposed of and replaced.
Yeah.
In some ways, they might be superior.
Yeah.
they might have a lot to teach us. So the
Yeah.
other direction to me just seems so much more important, is so much, has so much more potential and interest. Like it's like it would just seem nutty to me to like, I'm not, for people, if somebody, I'm not judging anyone else. If someone else finds it meaningful, go for it. But
Yeah.
for
No, totally.
me, yeah.
But along those lines, in terms of the interface, I mean, again, as we said at the outset, and I'm sure the audience knows, you're kind of the originator of VR, right? I mean, it kind of begins with you and your company,
Well, just
or
to clarify, the very idea of putting up head track 3D, that goes to Ivan Sutherland, who also invented 3D graphics in the first place. What I did is I did the first social ones with avatars. I did the first commercial ones. I did the
yeah,
first ones that were head supported and where there were sort of goggles that looked like what we currently think of. So, and I made up the term virtuality and blah, blah, blah. I did a
sure,
lot of stuff. So we should clarify, but
sure.
in some sense, perhaps, yeah.
But profound connection to it in any event. And,
Mhm.
just recently, I don't know, a week or two ago, I mean, Apple comes out with, its version.
Yeah,
Have you
yeah.
have you have you I'm sure you've tried it probably long before,
Yeah, so I mean, there's a long history to that. Oh my God. Um, 40 years ago, when the Mac was shipped, some of the key people from the Mac, including Andy Hertzfeld, who wrote the first Mac OS, came over to help us with the first VR OS and to ship the first VR system.
yeah.
And the first commercial headset was called an iPhone, but spelled EYE.
Huh, I
And
didn't know that. That's good.
there's, I don't know exactly what the story, but I've been told by a number of people that that directly led to the iPhone with an I,
Huh.
because the original idea from Jobs and others in Apple, when it was a very small nascent thing, when the Macintosh hadn't even shipped yet, was that someday Apple would sell a headset, and we all estimated it at 2010.
Oh, that you thought that's when
Back
the
in
yeah.
1982 or three or something, we estimated 2010,
Well, that's
which
actually pretty good,
terrible, not
yeah,
terrible, yeah.
yeah.
So, but yeah, so there's always been a certain contingent that continued within Apple that wanted Apple to eventually get into headsets. And so, um, and we've known they've been working on this specific thing for a long time. And I I don't want to get into the details, but I had some access to earlier versions of it and whatnot. And um, I'm glad they're doing it. I think it has a ways to go, but I'm happy it's there.
But you don't seem particularly excited about, am I reading it
I
wrong, or
I'm cursed. I've seen all, like this is I I would like sometimes I really do wish I had a different past so I could be more startled by some of these things. Because I see people using VR devices these days, or I see them using Chat GPT and being so surprised and typically delighted, occasionally horrified, but um I'm sort of jealous of those who can enjoy that, surprise.
but I'm wondering about that because every time, for instance, I teach quantum mechanics or special
Mhm.
relativity, it's as if I've never seen this subject before. I find it so amazing that we were able to figure this stuff out and how it works when it tells us.
Oh,
Do you not have that
I
sense
have
of
that for the underlying science. I totally have that.
mm,
The particular product experiences are a little different. Um,
right?
this might be, oh, I don't know. Let's say one of these fusion startups starts to work, and there's like a fusion energy source, and there's a slight chance that you would be a little less startled by it because you would have read the paper, you'd
Sure.
understand it.
Right. Yeah,
And
that's
oh
yeah.
yeah, okay, there it is. They describe the process. It makes sense. Here it is. Here's what
Yeah, I
fits
like
in.
that analogy.
You know what I mean? And so
Totally.
that doesn't mean that you're any less interested in it, that you don't find the underlying physics delightful. And I do very much. I mean, I'm still totally interested in the physiology, the eyes, the
Yeah.
cognition. The optical challenge of doing a proper optical pass-through is still not really solved, and really, really interesting, and right on the edge of what we understand about light and how to manipulate it with materials. It's
Yeah.
great. I still get great joy from it.
Now I heard you once talk about a virtual reality general relativity
Yeah.
thing, which I've never seen, I've never experienced. What was that?
Oh gosh, there've been a zillion of them. I use this as an example of something about VR, which is that it's really harder to maintain apps in VR over the years than it is in other formats. So
Yeah.
I first encountered somebody doing a relativity experiential teaching thing in VR around 1992. I don't remember it very well, and I believe they were from somewhere in upstate New York, probably Cornell, but I'm not
Okay.
positive. And I might have that side. It's just so long. But at
Yeah.
any rate, you would go in and you'd be in this thing where things are warped. And if you tried to move your body, it would kind of distort. And there have been some that demonstrate special, some that generate general.
Yeah.
They've been around for, but the thing is, every single one of them only lasted a year.
Right. Right. Because the
And
technology
that's
moves on and you
that's
can't. Yeah.
yeah. So like, let's say I say this with love. The first generation Apple headset has a rather narrow field of view. Um, HoloLens was worse, so I'm not saying they're any, but they're trying to do something a little harder than what other people have done. So they have this thing. As soon as you make it broader, you can't just use the same apps anymore. Everything's going to have to be redone because it's
Yeah.
so fundamental.
Sure.
And
Sure.
so when somebody, let's say somebody says, okay, we're going to do a great relativity teacher thing for this Apple headset, a year later,
Won't
they're
work.
going to have graduated school. They're going to be in different things. It's not going to get maintained. It'll
Yeah.
fall all away.
No, I hear
And
you. I
yeah.
hear you because we made, I mean, it turns out that we World Science, we work with Verizon and we made these virtual reality experiences, one of which is what's it like to move near the speed of light. So we have this,
Okay, great. So
you
you
know,
made one. Is it still
but
working and used by anybody?
but the people who we work with to develop the underlying
Mhm.
programming constantly need funding to keep the
Right.
experience able to run on the next generation, this, that, or the other thing. It's like,
So,
yeah,
so
I
the
know
thing is,
exactly what you mean.
so the solution to that, in my opinion, is generative AI, because one of the best successes of generative AI has been encoding, right? So we often see you. I've seen different measurements, but the lowest general improvement in productivity I've seen claimed from somebody who's done a serious study is 40% better. But then there are many that say, no, 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 it's much higher than that. I don't, but the point is, it's non-trivial. Like
Yeah.
programmers are more efficient. And one of the great things, and one of the things I've been working with my research interns on for the last few years, and it's been crazy successful, is prompt-based virtual world creation that's spontaneous while you're in it. So you go around
Oh,
and you say,
really?
I'd like a relativity simulator. And furthermore, I have ADHD and I'm colorblind or whatever. That's it,
Yeah, sure.
and I'd like it to be this and that. And it should just come up. Like you shouldn't have to go through this whole process of developers. Now, I don't know, Apple might not like that because they like to be more control. So it might not be on their
Sure.
ecosystem. I don't know. That'll be up to them. But the point is that that's the way around this problem. And I'm kind of
So you
finding,
just build it fresh every time you need it, as
yeah, and you
opposed
don't
to,
even
yeah.
bother saving it because it's not, it becomes a non, it's just this thing you asked for, there it is, and then you ask for it again, and it might come, or maybe you can save it if you like a particular.
This really does feel like the holodeck right? I mean, you go in there and you just
Yeah,
create a world with a few prompts or something.
well, sure. And I mean, not to put too fine a point on it, but back in the day, my group and the people who made the Star Trek were talking, and that's not entirely a coincidence at all.
Ah,
There was always kind of the vision. So yeah.
wow, that's amazing. But do you see, let's just take VR as a case in point. Do you
Hmm.
see VR as going beyond cool experiences and actually shaping our understanding of key ideas and issues and philosophical conundra that we have tussled with throughout the ages, and now by virtue of creating these worlds and experiencing things differently, we could shed new light on these old problems?
Well, okay. So my experience of VR is that it shines at sort of two extremes. One is extreme utility, which is and there it's been a great industrial technology for decades. It's been universally used to improve designs of planes and automobiles and ships and spacecraft. It's almost universal. It's been used for surgical procedure design and training and real-time assist. It's been used for city planning and all that stuff. And that's a whole separate ecosystem that people don't even see. It's different
And
heads.
that is ubiquitous. I mean, I'm less aware that like city planners have made use of
Yeah,
these
it's
tools.
the vehicle prototyping, I would say, is universal. City planning is very widespread, but not universal.
Yeah.
Um, yeah, and so there's an ecosystem that supports those people. It's rapidly in the hardware of it is rapidly merging with the consumer devices as always happens. However, it has its own world of software and distribution, its own culture, its own people. It's like another thing.
Yeah.
And it's a set of different niches. People designing chemicals, drug for drugs and for all sorts of other things, for industrial
Yeah.
processes, organic and inorganic. And
Sure.
then there's anyway, so there's that world, and that world's great. I love that world. But then there's the other extreme, which is the crazy art stuff. And that, it's very subject to interpretation, because what happens is you might create a virtual world experience that, at least for me, seems to teach a very specific lesson about philosophy and thought, but for somebody else, it might teach a different
Sure.
lesson.
Yeah.
Uh, there's no way to perceive without your pre-existing philosophy coloring what you perceive. It's just not possible. So
Yeah.
for
Yeah.
me, when I'm in a virtual world and I make everything really weird, you can change your body into animal bodies, which is an amazing thing about cognition, and you can change the perception of the flow of time and many, many other crazy things. But the more crazy it gets, the more you notice that there's this thing in the middle, which I call the little nub sometimes. It's like your consciousness is there. So it's a consciousness noticing machine. And I'm an unapologetic dualist. I think consciousness is a thing apart. I think experience is a thing apart.
Really? That's a whole
Yeah.
other conversation that we should have
Yeah.
at some point. But yeah.
And I love fighting with people about it. I used to make a living fighting with people like Daniel Dennett. Oh, actually, his book's right here. The proof.
Sure. Yeah.
I
Yeah.
I would argue with him and other people about it for money, and it's great. I love it.
Yeah.
But anyway, so I'm a diehard dualist. I believe in experience and consciousness as a separate thing. I think we need it in high-tech times in order to identify who the beneficiary of the technology is. I think if we blend people into the background, we can't identify who we're doing this for anymore. So there's a new pragmatic reason to care about consciousness. But whatever. So that's what I get out of it.
Yeah.
I totally recognize someone else can go to it with a different philosophy and get a different message.
No, totally. Even as a non-dualist myself, one of the things that has always struck me as interesting, this framing of Thomas Nagel in terms of, how do you understand whether something has an inner world? Is there something that it's like to be that entity? And of course, use the bat as his primary example.
The
What is
bat,
it
yeah.
like to be a bat? Now, if you can go into a virtual world and really be a bat and really experience what it is to be a bat, perhaps your consciousness can shift in a way and get closer to the consciousness of a bat, just as a concrete example. And I think philosophically, those kinds of experiences could have an unusual impact to really shift the discussion.
This is my very favorite stuff about virtuality, really. Like, this is for me the very best way to use it and the very coolest thing. I love this.
Yeah.
Yeah.
So one hopes that that's where this will all go at some point. Well, Jan, we're out of time. It's been a fascinating conversation, one that, if you're willing, I'd love to have part 2 at some point, because I feel like
Sure,
there's
yeah.
so much more to talk about.
Very
But thanks so
happy to.
much. Thanks so much for joining us. And look, best of luck in pushing the frontiers of all these fields going forward. And it's really exciting. Thank you.
Cool. Really, really nice to talk to you.
Great to see you. All right, everybody. Thank you for joining us. That's our conversation for today. Again, sign up for World Science Festival newsletter or join our YouTube channel to be alerted when these various conversations and programs are brought forward, when they're posted. And also, you should know that we are going to have a nice live event in New York City toward the end of May here in 2024. So if you find yourself in New York around then, you should certainly join our live programming. Thanks so much for joining us. I'm Brian Greene from New York World Science Festival. See you soon.